Good morning. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Now, today's video, I'm going to get into an engineering subject. Now, the reason why I want to get into an engineering subject, or let's say an engineering discipline, because I'm doing mechanical drafting. Of course, if you go to any drafting school, you're going to learn a lot about auxiliary drawings. You're going to learn a lot about isometrics, orthographics, but a lot of these drawings are basically geared toward mechanical engineering. Now, what is mechanical engineering? Mechanical engineering is a discipline that basically applies engineering physics. The physics that you're going to get is the mechanics, and I'm talking about statics, dynamics, and mechanics of materials. Now, when you deal with statics, you deal with objects that don't move. When you deal with dynamics, you deal with objects that move. In fact, you have centrifugal acceleration that's involved with dynamics. And then when you get to strength of materials, some call it mechanics of materials, then you're going to deal with stresses and strains of materials. Also incorporated into mechanical engineering, you have engineering mathematics, material science. Now, material science, you deal with your polymers and you deal with your electrical material. Now, what mechanical engineers basically do, their principles are basically set to design, analyze, manufacture, and maintain mechanical systems. Now, besides civil engineering, mechanical engineering is one of the oldest professions. Now, the mechanical engineering field requires a deep understanding of areas, and I just mentioned one of them. I talked about mechanics, talked about dynamics, thermodynamics, because you deal with engines like the Carnot engine. You deal with HVAC, material science, structural analysis. Now, the structural analysis in mechanical engineering can go along with the structural analysis in civil engineering, because you could be designing a crane inside a factory structure. Also, you deal with electricity. There's a new field out called mechatronics that combines electrical and mechanical engineering, and this is where you get into automation and robotics. Now, in addition to these principles, mechanical engineers use tools such as CAM, computer-aided manufacturing. There's computer-aided design, known as CAD. And there's product life cycle management. Now, there's some break-offs of mechanical engineering. I'll get to that in a few. Now, again, when you deal with mechanical engineering, they like to analyze industrial equipment. They design industrial equipment. Again, they deal with machines. They deal with your cars, manufacturing plants, industrial equipment, machinery, heating and cooling systems, transportation systems, aircraft, watercraft, medical weapons, and others. Now, mechanical engineering is the broadest discipline of engineering because it overlaps in other disciplines of engineering. It's a branch of engineering, of course, that involves the design, production, and operation of machinery, like your printers, your toasters. Now, mechanical engineering emerged as a field during the Industrial Revolution in Europe in the 18th century. However, its development can be traced back to thousands of years around the world. Now, in the 19th century, developments in physics led to the development of mechanical engineering science. Now, let me tell you something about engineering. Engineering is basically, it comes from three sciences. It comes from biology, chemistry, and physics. Now, when it comes to mechanical engineering, the field has continually evolved to incorporate advancements. Now, today, mechanical engineers are pursuing developments in such areas as composites, mechatronics, nanotechnology. It also overlaps again with other fields of engineering, aerospace, metallurgical, civil engineering, electrical engineering, manufacturing engineering, chemical engineering, industrial engineering, and other engineering disciplines to varying amounts. Now, I'll talk about those other branches later. But mechanical engineering, if you're interested in that, you may also work in the field of biomedical engineering, where you design medical devices, specifically with biomechanics, transfer phenomena, biomechatronics, nanotechnology, and modeling of other biological systems. Now, again, when it comes to mechanical engineering, your coursework, you have a lot of heavy subjects. Again, there's mathematics, your differential equations, your calculus, your linear algebra, statics and dynamics, strength of materials, solid mechanics. You deal with fuels, the combustion engine, fluid mechanics, mechanisms, and machine design. That includes kinematics and dynamics, instrumentation and measurement, manufacturing engineering. In fact, manufacturing engineering and industrial engineering are basically break-offs of mechanical engineering. Have to deal with vibration and control theory and control engineering. Now, control engineering also is a break-off of electrical engineering. Again, mechatronics. Mechatronics involves electronics, computer programming, mechanical engineering or electromechanical engineering, engineering design and product design, drafting, computer-aided design, again, CAM, computer-aided manufacturing. Now, when it comes to mechanical engineering, they're also expected to understand and apply basic concepts from chemistry, physics, biology, or tribology, chemical engineering, civil engineering, and electrical engineering. Again, mechanical engineering is a broad field. Now, some of their job duties are to analyze problems to see how mechanical and thermal devices might help them solve the problem. They design or redesign mechanical and thermal devices using analysis and computer-aided design. They test and develop prototypes. This is why when you get into mechanical engineering, you have to understand CAD. There is a program out there called Inventor. I use it. You draw a 2D sketch, you extrude it into a 3D sketch. Again, when you do your drawings, if you're going to go into mechanical engineering, you need to learn about sketching because you're going to sketch 3 views of a drawing. Now, drawings basically have 6 views, but we only use 3 views. In the top, the front, and the right side view. Draw a lot of parts. So you have to understand line widths. You have to understand construction lines. Because in mechanical engineering, you're going to do a lot of 2D and 3D drawings. Now, mechanical engineers design and oversee manufacturing of many products ranging from medical devices to new batteries. They also design power-producing machines such as electrical generators, internal combustion engines, and steam engines, turbines. And one of my favorites when it comes to mechanical engineering, because I actually wanted to go into mechanical engineering one time and just do HVAC. You do a lot of your heating, ventilation systems. Now, with every branch of engineering, there's what we call sub-disciplines. So, breaking down the sub-disciplines of mechanical engineering, there's mechatronics now. Again, in robotics. Mechatronics is basically a combination of mechanics and electronics. Again, mechatronics is an interdisciplinary branch of mechanical engineering, electrical engineering, software engineering, or computer science. There's structural analysis. Now, structural analysis is a branch of mechanical engineering and also civil engineering devoted to examining how objects and why objects fail. And when you deal with structural analysis on the mechanical side, as well as the civil side, you deal with the stress and strain. And When it comes to structural bodies, talk about fatigue failure, static failure. Now, fatigue failure occurs because of imperfections of the object. Now, because drawings in the mechanical engineering side have a tolerance, and they have to have a tolerance because you cannot design a part that is perfectly related to the design. It's too expensive. This is why they have tolerances when it comes to mechanical engineering. Sometimes a design does not work, but structural analysis is part of mechanical engineering. Thermodynamics deal with heat. And the big one I told you about is drafting and design. Because of mechanical, you do a lot of drafting. You have to make your prototypes. You create instructions for manufacturing parts. You have to have your part number. You deal with drawings that you have to break drawings into sections. And when you have a sectional drawing, you want to see what's inside that drawing. That's what a sectional drawing is. And when you have your arrows are pointed upward, and that's basically on how the person is viewing that drawing. And if you have a drawing that's way too big, you break it. It's a conventional break. And this is where your CAD and your CAM come into play. Modern tools. Now, there are areas of research such as micro electromechanical systems. And those are components such as gears, springs, and you have your composites. Now, composites basically get more into your fiber, your materials type of engineering. That's known as materials engineering. Your electrical devices. You can also include wood, concrete, because you're dealing with a lot of civil, especially when you're going into the building site, because there are mechanical engineers who are involved with construction, but again, they're doing mechanical parts. Nanotechnology. Basically, you deal with creating molecules. Then there's finite element analysis and biomechanics. But again, mechanical engineering is a very broad field. So if you want to get into mechanical engineering, you got to know your math. Make sure you get into an ABET accredited curriculum. Now, there's also mechanical engineering technology, and I'm going to get into a video in the future that's going to give you the difference between engineering and technology. But if you're serious about mechanical engineering, just make sure you understand the courses that you must take. It's 120 to 128 credits, ABET accredited. But at the end of the day, mechanical engineering is a good field. It's very broad, and I am just giving you an overview. And that concludes this presentation of mechanical engineering. If you like what I just presented, please comment, share, and subscribe. Once again, my name is Leon Jones. Thank you for listening to this presentation from the Mind of STEM channel, where I'm giving you a daily dose of science, technology, engineering,